Hello everyone, welcome to Java Tutorials. My name is Kishore. In this video, we will discuss about the list interface, which is a part of collection framework. We understood the methods which are available in collection like add, remove, iterator, size, is, empty, clear. And this example, what we do is we will try to maintain simple types of data like numbers and strings, and we'll see how these elements can be added or can be removed. Firstly, to create the object of list implementations, you can use list reference followed by the type of elements you want to store, then variable name equals new class name that is implementing the list like array list or linked list. However, this T is very much important, which is going to tell what type of data the collection is going to store. It should always be the class name. It should never be the primitive data type. Means creating this is fine. Integer equals to new list of is equals to new array list, and you can keep integer here, or you can keep it empty at the right hand side. Automatically, the compiler is going to treat what kind of data array list is going to store based on the type you mention at the left hand side. Whether you keep this one empty or you write it, it's okay. What you should understand is you cannot write like this. This is wrong. You should always pass the class names, which are going to be integer, string, employee class, float, double, all the wrapper classes of the primitive data types you have, you can pass, and you can pass the user defined classes also. You can pass predefined class names also. Let us store integer. For that, I will use the list, and you have to import the list from util package. All the collection framework implementation classes interfaces are available in util package. You have to import it, and e means the type you need to mention here. I will write here integer, then list equals new array list. You can write. You might think that why did I use list equals to new array list? I could use array list equals to new array list, right? Yes, it is possible, but we always follow this polymorphic behavior by creating the super type reference, right? Where I would use the higher type and take the subtypes. Why didn't I use collection then? If I use collection, then I can only call the methods which are available in collection. But if I use list, there are some extra methods present in list. Even that also I can invoke. That's why I used list. I am going to use those extra methods in this example. In order to add the data, what we will do, we will use the add method. Notice the add method is taking integer. Let me change this. Look at this. Add integer. If I change this to string, automatically the add method argument changes. If I write, if I use this add method and use control space, you can see automatically it is changing to string. Means whatever the type you write in the less than and greater than symbol, as per that type, the add method changes. This is called as generics. So the array list is created that way. If you go to the source code of array list, look at the array list, the class name. It is telling array list E. And if you go to the add method, the implemented add method, let me search for add method. Look at this E. There is an add method taking E. So if you mention integer, this add is going to take integer. If you mention string, the add method will take string. If you mention customer, the add method take customer. That is why you need to mention the type here. So let me use integer for this example, and let me add some numbers like 20. And can I store duplicates in array list? Yes, you can store. Let me store 20 twice and also 40 twice. Then add 50. And you can print the list directly like this. List equals. And if I run the program, I should see all the elements that are added in the sequential order it is listing. But this is just displaying the content of the list. Though it is an object, it is printing the output like this, because when you print the object, the toString method of array list is actually implemented in such a way that the data should be printed in the square bracket, or the data should is going to return in the square bracket. In between the square bracket, the data are represented. Now, if you want to reiterate each element, you can use for loop, or you can use iterator interface also. For loop is only for reading, but you can use iterator when you want to remove the element at the time of iterating. So when would we get such scenario where we want to remove the element at the time of iterating? We will be getting that scenario also. Just you need to wait for some more time. What we will do now, let us simply use for loop. And how do I use for loop? I can use enhance for loop, and I can now use the int data type to iterate the list, or you can use integer. Both are okay. But when you are adding the elements, you should always declare the list with the wrapper class or the class names. Now let me print the value of x equals x, and if I run this program, I would see each iterated value present in the collection. But there is one more interface which you can use, that is called as iterator interface, whose main role is to iterate the element. This iterator interface again is a generic type. This T stands for the class names which you give in the collection that you want to iterate. And this iterator has totally three methods. One is as next method that returns boolean, then next method that returns the iterated element, and one more is the remove method which removes the iterated element. Now, what is going to how we are going to use this iterator means there is an iterator method, if you can observe here, in every collection. And how do I use this? You can use iterator. You need to import it from util package, and in place of e you should write integer it equals the list interface which has that iterator method you can invoke. And this iterator is actually coming from collection, correct? The iterator dot iterate the list dot iterator we are calling, and automatically this iterator would refer to the collection that list is holding, that is the entire array list, and it starts navigating. But you need to call the as next to check whether the next element is available to iterate. And what I will do is I will use in the while loop as next, and then what we will do, we will write one delimiter before the iterator and after the for loop, and I will write here x equals it dot next, and then I will print the value of x. You might think that how is it possible list is having integer, but we are assigning the iterated element to int here also, as well as it dot next. What is it returning? If I place cursor over it, the next method is returning integer because iterator is iterating the list with integer class. This is possible because Java will automatically convert integer to int type, and it can also convert int to integer type. This is called as auto boxing and auto unboxing. That facility is available. For that reason, it is possible. So if I run this program, I should see the elements which are going to be iterated. We are getting the same output for loop as well as in the while loop. But what is the advantage of using iterator means at the time of iterating, you can remove the element. Right now, it is just integer. The remove method may not be that much useful, but what if the list is having complex data type, like 20 employee objects it has, and each time you iterate, you are going to get the employee element, and you can check. You need to remove those elements whose salary is in between this range. Then every time the next method returns an employee object, you compare it with the condition. Is that employee object salary is coming in this range? Then you remove that from the list by using it dot remove method. Then you would be removing those elements that are iterated, which is going to match to the condition. Such things you cannot do with the remove method present in the collection, because this can remove a particular element. But what if you want to remove the elements at the time of iterating so that you can apply some conditions and you can remove? Then that remove method of iterator would be useful. Let me simply remove here one element. Let's say I write here condition if x is equal to 20. And what I will do, I will use it.remove. This is going to remove the iterated element which matches to the condition x equals to 20. And at the end, we will print the entire list. So list after remove. We will simply print the list like this. List equals list. And if I run the program, I should see list is removing that entire 20. No 20 is available, correct? So at the time of iterating, we removed. We also have the size method, isEmpty method, clear method. We will try to call these things. So what does the size do? Size is going to get the size of the collection. So after removing, the size is going to be how much? Let's see. 1 minute, there is an error. We will, okay. So let's run this program. You can see the size is 4. And there is a method called isEmpty also. So isEmpty would return true if the collection is empty. So isEmpty if I call, what happens is it returns false because it is not empty. But we can call the clear method to completely clear all the collection. And after clear, if I call the isEmpty, what happens? It has to return true. If I run the program, we get next time isEmpty should be true. Suppose you want to clear all the collections, like probably you have added some items in the collection, like in shopping cart application, and clear should be called when the clear button is clicked by the user. At that time, this clear would be helpful so that collection is empty and even shopping cart is also empty. This is just a simple example to understand how to maintain the element in the list. But if I observe the output, 20 to 50 it is displaying, and it is displaying this list, correct? And isEmpty is false, size is 4, isEmpty is true. What if I change this new array list? Let me remove this and write new linked list. If I create a linked list object, would the output change? Actually, the output will not change. If I run the program, look at the elements that are displayed in the same order how you have added. The exact output what you got for array list, the same output you get for linked list also. Even the remove is also working the same way. But the difference is in the implementation part, where array list stores the elements in contiguous memory address. Linked list stores the elements in non-contiguous memory address. Retrieval is faster in array list, and adding and removing is faster in linked list. But adding and removing is slower in the array list because in between the elements, if you try to add, you know the concept, right? It is going to copy each element to different memory address. In linked list, that won't happen. Next, coming to the next part, let me just comment out all these things so that I can write from the beginning. That is, let me add string. So let me add string here. To add string, you can use again some implementation like array list. Then let me add some string list dot add test, then list dot add, then hi, then list dot add t, like this. And now if I print the list, it should print that 4 elements. And I can also iterate by using the iterator. These are the 4 elements, right? What we will do, we will again use the iterator. This time we need to use iterator with string type. So again, we will use the iterator and we will mention string. It equals list dot iterator. We can again call the it dot as next method to check whether the next element is present or not. It is going to return true until it returns until it navigates to the last element. Once the last element is navigated, after the last element, as next is going to give false. And we will store the next element that is iterated to the string, because every time it iterates on the list, the iterated element is going to be string. That's why we need to assign to the string. Earlier we assigned the next method to int, correct? If you observe here, because it was iterating the integer. Now we are iterating the string. Now what we will do, we will try to write one condition. What is that? If s dot char at 0 is equal to h. What does this mean? Means we are matching the first character which belongs to h. The first character should match to h. Then only we will remove. And what happens now is it is going to remove those elements which are iterated, but the first letter should be h. And now after removing what is the entire list, we will see. If I run the program, I should see only test and t is coming, because every word that is having the first letter h is going to be removed. So that is how the remove method is useful in iterator. But one thing is, we have a remove method even in collection, this remove method. Let us use that remove method. Suppose I use the remove method in collection interface. How does this work? I can use list.remove. Notice the list.remove, there are remove methods like two methods. One is int and another from another taking object. So how these two work is, you can remove based on index number also. Say for example, you have some elements. Let me add some elements here. Let me add list.add. I will write here welcome. Then list.add by. Then list.add good morning. Something like this I will add, and let me run this program to see what is the output. If you see, it is showing test t welcome by good morning. And I can now remove based on index or based on object. The remove method based on object is present in collection interface. The remove method based on object, that is present in collection, and the remove method based on index, that is int value, is present in list. Let's use the remove method by passing the string, then it is going to remove based on object. So I will write here, maybe I want to remove by. And after removing, what it should print, by should be removed, correct? If I run the program, I should be able to see after removing that by is not there. But can I remove based on index? Yes, you can remove. Let me comment this, or I will remove based on index also. List.remove. The zeroth element I want to remove. What is the zeroth element? Zeroth element was a test. After removing, that test is not there, and it has removed by also, because we are calling remove method twice. So this is how the index based approach works. You can also add the element based on the index. See, after this, let me call adding based on index. That is list.add, and I want to show you the add method which is present in the list. That is, first parameter is integer, second parameter is the element. So you need to add the element based on index. So on zeroth index, I want to add maybe something called thank you. And after adding, if I print the list, what happens? Let's see. So after adding, the very first element should be the thank you. If I run the program, you can see after adding, thank you is there. But for string, it is okay. You can pass the object and you can remove. But for numbers, it won't work that way. If you try to pass a number which is present in the collection and you think that it is removing the number, it won't actually remove. Why? I will show you. First, let me pass 20. Do you think 20 is present? The index number 20, no, right? What happens if I pass 20? I should get an exception. Array index out of bounds exception, right? It means index bound out of bounds exception is coming because 20 out of bounds for length 4. So we understood that there is no index number 20. So the reason I commented was I wanted to show this part where if it is a number, you are adding an integer, and if you pass a number, will it remove? Let's see that. And now what I will do, I will comment out this one and I will uncomment the other one. So let me uncomment by using control front slash. So now we have a list with either linked list or array list you can take. Let me just add few numbers like 2, 3, 4, 5, then 1 and 6. Purposely I have added like this. Okay, 60, 10 also we will add. And let's run this program and see what is the output. So we are getting this from the for loop and we are getting the same output from the iterator, and after remove we are getting this element probably because we removed the value 20 with the condition 20, but it is not there. That's why the same element we are able to see, correct? Nothing is removed. But what I want to show you is what happens. I should remove this because it should not clear. So now it won't clear. The element size will be 6. Let me try to remove by calling the remove method and let me pass a number like 5. What do you think will be removed? Will it remove the element 5? Actually, no. The answer is it won't remove the element 5. It is going to remove based on the index 5. So what is the element present in the index 5? This is at 0. Have I added anything? Anyway, remove doesn't occur here. At this place, what is the element? It will be still 2, 3, 4, 5, 10, comma 60. So at fifth index, this is at 0, this is at 1, this is at 2, this is 3, this is 4, this is 5. Right? Will it remove 5 or will it remove 60? Let's see. So after remove, we have to print. So after remove, we are expecting 5 should be removed, but it removes 60. If I run the program, look at this. It is not removing 5, it is removing 60. So the remove method, which is taking a number, is not taking that number as an object. It is taking that number as an int. So how do I pass that as an object means you should use the remove method, and this time you should pass the object means not just by selecting that it is going to become an object. See, again, if I write 5, it is not going to remove 5. It is going to remove the element based on index only. If I run the program, I would get an exception because the fifth index is not there. After removing, only this much element will be there, and fifth index is not there. It is raising an error. So if you want to remove 5, you need to use the number as an object by using integer dot off method. And here you pass the value like this, integer dot value of method. It's not off, it is value of. So you should use value of method, and if I now pass 5, what happens is removes 5. Instead of considering that 5 as an index, it is going to consider 5 as an object. And next, when I print that list, I should be able to see the list without 5. This way you can use the remove method based on index, and you can use the remove method based on object, and you can use the remove method through iterator. So there are totally 3 different remove methods we called. You use remove of iterator when you have conditions, and then you need to remove, like I told, right, in the complex objects I want to remove the employee objects when employee objects are matching to certain criteria. Then you cannot use these 2 remove methods because these 2 remove can remove only based on index or based on the object. But this remove can remove at the time of iterating. You can compare each element and remove. And you use this based on index and you use this based on object. So that is how you add the simple type of data. In the next video, we will see how to add complex data and how to iterate, how to remove those complex data. Thank you so much. See you in the next video.